It's fine. So, good afternoon, folks. It's not surprising, first session after lunch, so not surprising to see this turnout. Yeah, so I'm going to talk today about managing a Gluster-based storage cluster using oVirt. So this is the agenda. Initially I'll give a little bit information about both these products, oVirt and Gluster. Then we'll get into the real topic of managing Gluster clusters with oVirt, which will include something about how the oVirt product works, what are the components and the architecture. Then we'll actually go into a video demo of how the UI works, what kind of REST API is available, and the CLI using which you can manage the clusters. And we'll also look at an interesting use case, which is about using a Gluster storage as a Virt store. So before we proceed, I know how many of you know about oVirt and Gluster. Okay, so not many. So good that I'm talking about them a little bit. So oVirt is a large scale centralized management for server and desktop virtualization. It is the open source alternative to products like vCenter and vSphere, and it basically works on top of KVM as the key virtualization technology. So it provides a full-fledged enterprise management solution for managing your virtualization environment, and the project itself is hosted at www.ovirt.org, and if you want to know more about it, if you want to talk to people who are behind this product, you can go to #oVirt channel on OFTC. Coming to Gluster, Gluster is a scale-out NAS storage solution. It supports thousands of clients and petabyte scale storage. Provides a single global namespace for your volumes. You can access volumes created in Gluster using various protocols like NFS, CIFS, or of late even object storage. It provides linear performance scaling. And again, the website for the Gluster community is www.gluster.org, and you can talk to the developers on #Gluster and Freenode. Now coming to the key topic, so how do these two projects come together when I talk about cluster management and oVirt, right? So we've been working on adding new features into oVirt for the last 7 to 8 months to enable management of Gluster-based storage using the oVirt product. So oVirt now is not just about managing your virtualization environment, but it will also now start supporting various capabilities related to managing your Gluster-based storage. Now, at the face of it, these two look little different, right? So you want to manage your virtualization or you want to manage your storage. So one of the things that has been done is the ability to morph this product, morph oVirt into either a purely virtualization management product or a purely storage management product. That is one of the things which has been done. At the same time, it also happens that these two products can actually work very well together and complement each other and become a single product. So one of the key things which have been done as part of this integration work is introduction of a configuration called as application mode. So if you set the configuration to 1, it becomes a virtualization only product. If you set it to 2, it is only for managing your Gluster storage, and setting it to 255 or 3 will make it a virtualization plus Gluster mode. So we are going to look at the Gluster only mode today, and also a little bit about Virt plus Gluster mode when I go to the demo part. Apart from this high level configuration, we also have enabled certain features at individual entity level. So when you create a cluster in oVirt, you are able to specify whether this cluster is going to host your VMs or is going to be primarily your storage cluster. And obviously we have introduced various new entities related to Gluster into oVirt, which include things like Gluster volumes, bricks, volume options, which are your tunable parameters, and VDSM verbs for Gluster management. If you are not familiar with VDSM, it will be clear in the coming slides. Okay, so this is how the architecture of oVirt looks like. As you can see, engine is the key central component here, which drives the whole functionality of the oVirt management UI. What you see on the right hand side are all the nodes or the hosts of your cluster which are being managed through your UI or the engine. In this particular case, since we are talking mainly about storage management, you will see that all of these are your storage servers. These are running the Gluster file system on them, and they also run a component called as VDSM. So VDSM is the component with which the engine interacts with to get anything done on those nodes. So engine always interacts with VDSM over the XML RPC protocol. VDSM is written on Python. Engine is a Java-based application server hosted in JBoss AS7. It exposes two interfaces to the other components. One is a GWT interface. So the whole browser-based UI is developed on top of Google Web Toolkit, and it interacts with engine through the GWT RPC over HTTPS. At the same time, engine also exposes REST API for all the functionality that it supports, and that can be consumed by any HTTP client. So REST being pretty generic in nature, one could consume it using any HTTP client. It could be your browser or a curl kind of a command line tool. At the same time, oVirt itself provides something called as a Python SDK. These are the Python bindings for your oVirt REST API, and on top of that SDK, it also provides a remote command line interface. So there is something called as a tool called as oVirt shell, which is a shell through which you can actually invoke the REST API and get all the Gluster management or virtualization management related stuff done using the command line interface. So this is how the various components look like. Of course, directory services is another component with which the engine interacts for authentication and authorization. Okay, coming to features, we will look at each one of these in the demo as well. So the first thing that you typically do is create a cluster. So you start with one server and start adding more and more servers and create your storage cluster there. So you can create a cluster, add and remove servers to it, and just in case you want to destroy, no more need it, you can delete it as well. When it comes to volume management, you could create the cluster volumes, add or remove bricks from it, start and stop the volume. So starting a volume means basically making it available to all the clients of your volume, and if you stop it, it won't be accessible anymore, and you could delete a volume. There are also certain interesting features. One is advanced search capabilities. So you will see in the demo that the search capabilities of oVirt are very powerful. You can it provides you autocomplete when you're searching for entities, and you could search various entities and their parameters in a very easy way. It also supports administration of various entities at different hierarchies. So there's a multi-level administration, so you can control either at a top level or a very fine-grained control over your entities by setting permissions at the lowest level. All the key entities, all the key events in the system get audited, and alerts get generated whenever there are events that need attention from the users. Examples of that could be CPU usage going very high, or storage getting consumed more than 90% kind of things. And I've already talked a little bit about the REST API, Python SDK and CLI. We are going to look at all of these. So let me open a video and go through all of these features. So as I said, first thing you do is assuming that you are interested in managing just the storage, Gluster based storage for your organization. So first thing you would like to do is to make all the virtualization related stuff disappear from the UI and focus on the Gluster part. So for that, what you need to do is set the application mode to Gluster only. Now this today, as it stands today, is something you need to do by doing a simple update in the database. Of course, we plan to introduce setup time options which will automatically do this for you. So what I'm doing here is stopping the oVirt engine service and then connecting to the database. And if you look at the current value of application mode, it is set to 255, which means it will support by default both Virt and Gluster. And now I'm updating it to 2. 2 means Gluster only. And now you have to start the service again. So once your service is started, you can log into the system and start creating your cluster. So you can see this is the kind of UI you see when you log into oVirt, which is running in Gluster only mode. So you can see that the system and a default cluster that is already available in the system. Now as it happens, the default cluster is by default a virtualization cluster, so we will not use it here. Rather we'll create a new cluster called Gluster. And now we'll start adding hosts to our cluster. So you can see in the UI, any cluster that has a G embarked on it is a cluster that supports Gluster capabilities. So you go to hosts. So by default the cluster is empty. Now we start adding hosts to it. So you provide a name to the server, provides IP address and root password. So what happens when you add a host to the cluster? So something called as bootstrapping starts. So you see the status as installing out there, and this bootstrapping has various steps in it, which includes checking whether all the required packages are already installed or not. If not, installing all those packages, setting the appropriate firewall configuration, and so on. So once the bootstrapping is over, the server reboots, and after it gets rebooted, it will go into an up state. Once you have added a few hosts to your cluster, you are ready to create volumes on top of it. So you see that this is a volume creation UI where you select the cluster in which you want to create a volume, provide a name to the volume, and set the appropriate type. So this cluster allows you to create different types of volumes. Distributed volume being the simplest one, where all the data of your volume is spread across various nodes of the cluster, whereas you could also create replicated, striped, distributed, replicated, and so on. In this example, we'll just create a distributed volume. Any volume consists of something called as a bricks. Brick is nothing but a directory on a server. So you need to select a server, provide a directory on that server, and add it as a brick. So we'll add 2 bricks on 2 different servers here. So volume has got created. You can see that by default it is in down state, which means no one can really access it from a client machine and start putting data into it. You can also see that there are sub tabs at the bottom for the bricks, volume options, permissions, and so on. So one of the things that you will do is start the volume to make it available to the clients. So next thing we'll see is how do you start, stop, and delete your volumes. So let's say we have created 4 volumes, all of them are currently down. You select all of them and click on start. The system will start bringing them up one after the other. So even though you select all of them and click on start, you will see that all of them won't go up at the same time. They will go up one after the other. So all these volumes are now up, which means anyone can mount it and use it. Let's stop one of these volumes. So you can see that stopping a volume will make its data inaccessible. You get this warning. You can still go ahead, and if you still go ahead and stop it, you'll see the status changing now. If any clients were connected to it, they will get disconnected. And you can delete a volume only if it is in stopped status. So we'll select the stopped volume and click on remove and remove the volume. Other things that you can do with oVirt is adding and removing bricks from your volume. So it is like elastic in nature. So even when a volume is running and people are connected to it, you can actually add more bricks to it, which means you'll increase the capacity of the volume, and you could also dynamically reduce the capacity when it's not required. So I'm adding a new brick called data new. So you can see that the brick will now appear here. And in the same way, you can select one or more bricks and remove it from the system. Yeah, so we are left with the previous 2 bricks now. Volume options, as I said, are configurable options of a volume which help you tweak the behavior of a volume. So again, you can click on the add button. You get a list of options which are supported. You could then choose any of them. When you select a volume, you see the description of it, which helps you in setting its value appropriately. So in this case, we are setting auth.reject, which means any clients, if a client's IP address is 192.168.2.99, it will not be allowed to access the volume, and it appears in the UI immediately. If you want to edit the value, again you can select the option and click on edit. Let's say we want to reject all requests coming from a particular IP range. So instead of 2.99, I make it 2. Star, and you will see that the modified value will appear in the UI. There you go. You could also reset the options, which means they will go away from, they are no more customized by you. They will go back to the default state, and the application will behave in a default manner as far as that functionality is concerned. The reset all option helps you removing all the customization of volumes you have done, and the system simply goes to the default behavior. Okay, now we look at how you remove a server from your cluster. So you can see that there are 2 servers which are part of this cluster here, .104 and .153. If you say Gluster peer status, you will see that these are connected to each other as part of the cluster. We'll now go to the UI. You can see those 2 servers here. So first thing you do to remove any server from the cluster is to put it to maintenance. When you put it to maintenance, it takes some time to prepare it for maintenance. In a couple of seconds, the status goes to maintenance, and now the remove button gets enabled there. And when you remove it, you will see that that particular server will get peer detached from the Gluster cluster. So if you go back to the command prompt and do the peer status again, you will see that these 2 are not connected to each other anymore. Yeah, so this is the additional stuff that happens when you remove hosts from a Gluster-based cluster. And the last server is something you can just put it to maintenance and remove again. So now you have gone back to a blank cluster which doesn't have any servers in it. So the key thing to remember here is you cannot remove all servers at once. There should be at least one server which is in upstate before you remove all of them, and the last one can be removed without any issues. So another interesting feature is importing an existing cluster. So it's quite possible that someone has created a Gluster-based storage cluster using the very easy to use and powerful Gluster CLI, and you already have a cluster which you created using CLI, and now you want to start managing it using oVirt. So this particular feature allows you to import such an existing cluster into the management UI and then start performing all the management from the UI. So again, we have the same two servers. Let's assume that you have created using CLI, and there are absolutely no hosts in our. In fact, we don't even have a cluster. So we are creating a new cluster called existing, and we say I want to import an existing cluster configuration. So I provide IP address of one of the servers of the cluster, and system automatically detects the fingerprint and shows to you. You provide the root access. Now it detects all the servers of that cluster and shows you in a list. You could verify the fingerprint, provide the root password for all the machines. In my case, it happens to be same password for all of them, so I just provide it once. And when I click on OK, you'll see that both the servers will get added to the new cluster called Gluster here. So there's a new cluster called existing, and inside that you can see the two hosts that we just saw on the command prompt. Let's look at the powerful search capabilities that I talked about. So let's say I want to search for all volumes whose name contains E. So I say volumes : name equal to star E star. So all kind of regular expressions you can use to search volumes here. Once you find volumes with name E, let's say I want to look at only ones which are in up status. So I say and status equal to up, and you'll see that the down one will go away. And let's say I want to look for only the replicate ones, so only one of them will remain now. So a replicate type of volume, the distribute one goes away. Right, so very powerful search mechanisms. You can also see that there is an event tab at the right hand side where you see a list of all the events which are happening in the system. Events are something which you can look at various contexts in the system. So this is one where you are particularly going to events tab and looking at what is happening. At the same time, you could also go to a bottom pane which is always available, whether you are looking at cluster, a host or a cluster volume. You'll always be able to look at all the events happening in the system, the latest one being at the top. Also, when you select a particular entity in the system, let's say when you select a particular volume called REPL here, you again see a tab at the right hand side called events, in which you will see only the events related to that particular entity. So here you see only events related to this particular volume right from the time it got created. Right? Okay. So now we come to we have sort of looked at most of the Gluster storage management capabilities we have introduced into oVirt. Now we'll look at how oVirt and Gluster now work together. How you can use a volume created using Gluster as an underlying storage for your virtual machines, right? So basically we are trying to use a Gluster volume as a word store. So what is involved? So first thing you'll observe here is I have gone back to the oVirt mode where it supports both virtualization as well as Gluster. So I have a cluster called default which supports virtualization, and I have a cluster called Gluster which is my storage cluster. You can see that I also have a volume here called word store which is currently down. So first thing I do is select the volume and click on a button called optimize for word store. So what it does is it internally sets a few of the volume options to tweak it for usage as a word store. You'll see some of the options started appearing in the volume options page, and then you can start the volume. So now you have optimized the volume to be used as a word store and started it, which means now it can be used as a word store. So the next step you do is creating a POSIX-FX based storage domain in oVirt, which is based on your GlusterFS volume. So you go to the storage tab and try to create a new volume, new storage domain. So here you can give your name to the storage domain. The interesting things to observe here are the data center in which you are trying to create the storage domain must be of the type POSIX compliant FS. So GlusterFS being a POSIX compliant FS, you can create a storage domain based on GlusterFS. So type is POSIX-FS. The host you select must be the hypervisor host, which belongs to the Virt cluster, and in the path you use the IP address you see there is IP address of one of the nodes of your storage cluster. The host name : /volume name, and use the VFS name as GlusterFS, case sensitive, and then it will create a storage domain. From then onwards, it is usual virtual machine management. You can create VMs on top of that storage domain, and it will internally use the Gluster volume as a storage. Okay, now we'll look at some of the REST API related features. As I said, REST API itself can be consumed in various ways. So you look at one example, which is curl tool. So you can see here that I have given a particular URL which says API/clusters, which means I'm trying to get a list of all the clusters which are being managed by the system. You can also see that I've given a header called accept application JSON, which means I expect the output of this REST query in JSON format, and I've also provided the authentication details. So when I issue this command, we expect the system to provide you all the details of all the clusters in the system in JSON format. So you can see the last one being a cluster called Gluster, and you can also see that the two interesting flags which we talked about, where Gluster service is set to 2 and Virt service is set to false, which means this is this cluster is used for managing the Gluster storage. You could also issue similar GET requests from a browser. You could also use some REST plugins that are available for Firefox and Chrome to issue even other types of requests to your REST service, like post requests, delete requests, which help you modify the entities or delete the entities in the system, create new entities. So without getting into that, we'll now get into the interesting part called oVirt shell. So as I said, oVirt shell is a command line interface which is based on top of the oVirt SDK, which internally consumes the REST API. So you can see that I'm getting into the shell. So when you type oVirt shell, it gets into a SQL kind of a prompt. The first thing you do is connect to a particular engine instance that is running. So I connect to it, provide authentication details. You can see it's connected. And let's say I want to look at a list of all the volumes from the cluster called Gluster that we just looked at. So we are saying cluster identifier is Gluster, give me a list of volumes. There is just one volume called data there. Let's say we want to look at how the data volume looks like, right? So we say show Gluster volume or data from the same cluster. Now you see all the attributes of that particular volume. Let's say we want to look at what all bricks are present inside this volume. So you can say list bricks from the volume identifier called data in the cluster called Gluster. So you can see there are 2 bricks there and the IDs of both of them. You could also look at a particular brick and see what server it belongs to and what is the path of that brick directory. So we say show brick, provide the brick ID and the other details, and now you can see that this brick is nothing but /export/data on a given server ID. Okay, now let's see how we can create a new volume using this remote oVirt shell. So you can say add Gluster volume. Right? Add Gluster volume. You have to provide which cluster you want to create the volume in. Name of the volume is video and it has 2 bricks. Export video 1, export video 2, both on different servers. So if it succeeds, it will come back with a success message and also provide details of that particular volume. So now if we list all the volumes in the same cluster, now we should see 2 of them. So you can see Along with data, you got a volume called video also up here. You could then look at the details of video or even the bricks that you created inside it. So once you create a volume, as we talked about, volume is by default in a stopped state. So one of the things that you need to do is start the volume. So you can perform actions also. So the command for actions is action. So say action cluster volume video. So basically we're trying to say perform the action called start on a cluster volume called video. So you can say that action is complete, which means the volume is started and available for use. And after, if you want to stop and delete the volume, you could perform similar actions. So the next action we'll see is the stop. And finally, separate command called remove for removing a volume. So we say remove video, it removes it, and we should, if you look at the list of volumes now, you should see only one volume. Yeah, there you go. Okay, so we are through with the video. We've also looked at Gluster as a word store as part of the video, so no need to really go over this in detail. So as you can see, there are just two key steps there: optimizing a volume to be used as a word store and creating a storage domain based on that volume. There are some important features coming up in oVirt 3.2 and beyond. Import existing clusters is something which you just saw. It's already there, available on the upstream. You will have features like setting up geo-replication sessions across two different geographically remote sites, advanced details of a volume including its performance statistics. Gluster supports lifecycle hooks, so you'll be able to manage those lifecycle hooks through the UI. Currently, one of the key features missing is ability to start the asynchronous tasks on the cluster and monitor and manage those tasks. For example, some of the important things related to cluster volume are called volume rebalance or migrating a brick from one machine to another. So these are the stuffs which are asynchronous tasks that take long time to run, and they run in the background. So currently there are no features to monitor these kind of tasks on a volume and manage them. So that is something which we are working on and should come pretty soon. A configuration of unified file and object storage for Gluster will come up. Not just managing Gluster, but also managing all the storage devices attached to your host, and then making use of these automatically detected devices for creating your bricks. That is another powerful feature you can look forward to. Ability to store historic data in a data warehouse and create reports out of that is another one. And there are quite a few features lined up. How can one contribute to these projects? I mentioned the websites in the beginning. I'm also mentioning some of the URLs of our Git repositories. So the oVirt essentially has two key components. One is the oVirt engine and the VDSM. So you have two different Git repositories for them. And there's a lot of activity on the IRC channels for both oVirt as well as Gluster. So feel free to hop onto these channels and talk to the developers to know more about these projects. So, any questions? Yeah.
Basic question with regard to error handling. So, You showed me the GUI when everything goes fine.
Yeah.
Okay. And things normally don't go fine.
Yeah.
So what kind of errors can you actually handle through your oVirt, and actually what kind of reporting do you do, and do you have any plans to embed some help and nothing like that?
Yeah. So anything that goes wrong, so let's say you try to create a volume and Gluster for some reason says it cannot create a volume. Okay. The brick directory you have provided does not exist. Okay. So any such errors which come out of the end command that we are firing on the system to manage it, if that command fails or anything else goes wrong in the system, the error completely flows back right to the UI, and you will see in the event log you will see error logs also. So the event logs you see, if I can open the video again. So if you look at this event log, it also contains the red cross marks. These are all the error conditions or alerts in the system. In this particular case, you can see that it is typically talking about low disk space available on one of the servers, but you would also see things like volume could not be created, or one of the bricks of a volume has gone down. Could also something that could come up here, right? So currently, any error happens either in the engine or on the VDSM or in the Gluster CLI will flow back to the UI and come as part of the events page that you see. There will also be some more advanced kind of alerting mechanism which will come up, which we are thinking about and will start working on, which includes giving intimation to the user about suspected problems. And all these events can also be subscribed to for email notifications today. So one could go to a UI where you can go and say, I'm interested in whenever a volume creation fails, or whenever someone stops a volume, I want to get email notifications. This kind of subscription is possible today, and it will send email notifications. We are also looking at providing other types of notifications, for example, sending SNMP traps, so that this system can get integrated with other enterprise monitoring systems like Tivoli Enterprise Console or HP OpenView or things like that. So, does that answer your question?
One other small question is, the communication to the remote servers is via SSH?
No. Communication between engine and the remote storage or Virt nodes happens over HTTPS using the XML RPC protocol.
Okay.
So, no more questions. Okay, thanks a lot everyone.